with the what the FT, right? If I remember it correctly. Okay. By the way, we don't have class this Friday. Okay. Uh, I'm start grading the midterm exam for this class now. Okay, I finished grading the from the previous class, and I'll post the exam probably if the long weekend I have time to grade your exams. I will post the scores for you. Okay. Anyway, uh, and I just realized I should not have given you too many questions on the exams. Okay, maybe it just should reduce the number of exams, the number of problems in the exams. It was too much for me. Anyway, it's too much to grade, basically. Okay, maybe I'm thinking maybe final will give you multiple choices. It's easier to grade that way, but I'm not sure. Okay, I'll see. Where is it? Where were we? Do you see the screen I'm sharing? The notes I'm sharing? I hope so.
Yes.
Oh, is it here? Yeah, this is the midterm exam. Okay. Here. Oh, last time I asked you to find out these numbers, right? Uh, oh my. How did you find this out? Okay. Hold on 1 second. Let me. Yeah, basically, this is just plug-in numbers. Okay. Uh, okay. Did you find out what these numbers are? Did you have time to do that over the weekends? Let me let me check with my. Hold on a second. I need to turn on my computer then. Okay, because it's not. Okay, I'm sorry. Do you calculate any of these? Uh, can you share with us if you have calculated them? I'm opening the file. Uh, I have it in the file somewhere. Maybe I should. Hold on. Okay, where is it? What page is this? 94. Okay, hold on. Let's see. Okay, 94. Okay, what's the first value? What's the first value you have? Anyone? We got -1, right? Okay. For the second one, x zeros. Okay, so the first value is -1. So we got this. Okay. X at -1 is -1. How about x as zeros? X as zero, same here. Okay. You plug in the numbers. Okay. Uh, how about use the blue one? So it's 1/3 summing, okay, k from 0 to 2 of 2 minus 2j psi, uh, what, 2 pi over 3k, right? And then times e to the positive j 2 pi over 3k times n. But in this case, n is 0. Okay. If n is 0, e to the 0 is 1, right? So we just have 1/3 of what? Uh, 2 minus 2j size 0. Size 0 is zeros. Okay, size 0 is 0. So it's just a 2. And then plus 2 minus 2j psi 1. So it's psi of 2 pi over 3, right? And then plus 2 minus 2j side of, when k is equal to 2, t is equal to 2 is 4 pi over 3. Okay. And how much is that? How much is sine of 2 pi over 3? Sine of 2 pi over 3 is This is pi over 3, right? Pi over 3. 2 pi over 3 is here. Okay, 2 pi over 3 is here. So it's what? Square root 3 over 2, right? Yeah, okay. That's square root 3 over 2. And 4 pi over 3 would be here. Negative. This is 4 pi over 3 is negative square root 3 over 2. Okay, so these two terms cancel. We got 2. Okay, 2 plus 2 is 6. 6 divided by 3 is equal to 2. Okay, yeah. So the second one at x equal to 0, we got a 2. Okay, got a 2 here. And we repeat the same thing for x1. So x1, we got the green one. How about? Oops. My. You go ahead and fill in the blank and calculate that. What you get for x1? What you get for x1? What value did you get for x1? Okay. What's the value for x1? 1. Kitty, what say 1? Okay, good. How about the rest of them? X2, X3, and X4. Okay. What are the values for X, what? X2, X3. How come it says X? Oh gosh, say X. How about I just say X2, X3, and X. Okay, go ahead and answer that. What are the value for X2, X2, X3? Xn is equal to n, not quite. No. X2, X3, and X4 will be negative 1, 2, and 1. That's right. Okay. Yep. Okay. So basically, we're going to have like this. Okay. This one, negative 1, 2, and 1. Negative 1, 2, and 1, like this. Negative 1, 2, and 1. Negative 1, 2, and 1. So basically, you can see that what happened. What happened? Can you guess? X negative 2. X negative 2 would be 1. X3 would be 2, and X negative 4 would be negative 1. Okay, you can see that it is periodic. Okay, it turns out that, okay, you can see that it's periodic with period. Okay, note that Xn is periodic with period 3 sample. Okay, as well. Okay, this is what happened when we discretize the frequency domain. Okay, if you go back to the previous examples, where was it? Where was it? Okay, if we do this one, okay, this is DTFT. Okay, if we do this one, DTFT, what we have here for these graphs, okay, for the xn, okay, for the xn, okay, for the xn, we got x0 as a 2 and x negative 1 as a negative 1 and x1 is a 1, okay, but everything else was zero, okay, we got everything else was zeros here, okay, this is DTFT, okay, xn is non-periodic, okay, omega is continuous, okay, omega is continuous, DTFT is non-periodic. However, once we discretize omega and we got DFT, okay, once we discretize it, okay, we discretize omega, okay, once we discretize omega, what happened in the in the time domain, it becomes periodic, okay, so when we discretize omega, okay, xn becomes periodic. Okay, and what's the periodic functions? This one is periodic with period n equal to 3. Okay, so if you use capital N, you sample one in one period in the frequency domain. Okay, if you discretize it 3 samples for one period in the frequency domain is what, 2 pi, right? If you discretize it 2 pi, it's gonna becomes periodic in frequency in time domain as well. You can see that. Okay, this is the relationship between time and frequency. Okay, it's just like Fourier series. Okay, it's just like the CTFS, right? The Fourier series is discretized in what, for the Fourier series, xt was periodic, right? And it becomes ck, right? It becomes discretized in frequency. Okay, frequency is discretized, omega is discretized. The this one is periodic. Okay, time domain is periodic. Okay, same here. Okay, but this one is periodic, is discrete time periodic. Okay, what happened if you increase n equal to 5? Okay, if you increase n equal to 5, so what do we have? We got 1 over 5, right? N equal to 5. This is 2 pi over 5, and that's 1 over 5. Okay, it's probably easier, okay, it's probably easier to do is in metrics. Okay, you probably want to do it in the matrix form instead of writing like this long way. Okay, we can form a matrix. Okay, remember, this is n. Okay, n equal to, this is n. Okay, so in each row, n equal to negative 1, negative 1, 0, 1, 2, 3, 4. And for this one, it's for k. Okay, this matrix here. Okay, this vector here. Okay, this vector here, you put k in. Okay, so k must be from what, 0 to n minus 1, which is 4. Right? Yeah. So k would be 0, 1, 2, 3, 4. Okay, that's the k. Okay, this is 2 uh 2 minus 2j psi 2 pi over 5 times 0, 1, 2, 3, 4. Okay, and this matrix, okay, this matrix supposed to be this one. uh how about in green? Okay, this matrix supposed to be this one. Okay, it has both k and n. Remember, k would be, if it's multiplied with the vector on the right hand side, Okay. So it's going to be k from 0, k1, k2, k equal to 3, and k equal to 4. Okay. And for the row, it's going to be n equal to -1, n equal to 0, until n equal to 4. Okay. So it's going to be what? E to the power of k0 is 0, right? It's 1. Okay. And when n is 0, it's also 1, right? 1, 1, 1, 1, 1, 1. Okay. And for this term here, okay, this term here is going to be what? It's not 0, but it's going to be e. It's going to be e to the power of j 2 pi. K is 1, n is -1 over 5. Okay. So it's e to the power of -j 2 pi over 5. Okay. And you multiply with the 2, right? So it's e to the -j 4 pi over 5, e to the -j 6 pi over 5, and e to the -j 8 pi over 5. Okay, that's what we have, right? Yeah. Okay, and this is pretty much, you fill in the blank here. This is what? K equal to 1, n equal to 1, so it's e to the j 2 pi over 5, right? Yeah. Okay, and this is e to the j 4 pi over 5, right? J 4 pi over 5, e to the j 6 pi over 5, e to the j 8 pi over 5. Okay, and so on. Okay, and so on. Until at the end, you're going to have e to the j 4 times 4, 16, right? Is e to the j 16 times 2 is 32 pi over 5. Okay. Yep. That's pretty much what we have. Okay. And if you multiply the two matrices together, okay, if you multiply the two matrices together, you would see that, wow, how would you see that? We're going to get uh, here, okay, we're going to end up with what? Wow. X -1 would be -1, x0 still a 2, and x1 is a 1. Okay. And x2, 3, 4. Okay. If you calculate it correctly, it's going to be 0, 0, and then start at -1 again. Okay. And so on. Okay. So basically, this is what we're going to have. Okay. We're going to have -1 to 1, and then 0, 0. Okay, you can see it's going to be periodic with period n equal to 5. Okay, and then it's going to be -1 again, and then a 2 again, and a 1 again. And then it's going to be 0, 0. Okay, and on the right hand side is going to be 0, 0, and then 1, 2, and -1. Okay, you can see that it's going to be periodic with period, 5 samples. Okay, it's the same as this one above. Okay, except it got 0 padding. Okay, except it got 0 padding to make sure it is 5 samples. Okay, to make sure it's periodic with period, 5 samples. Imagine if you increase k, right? If you increase the k, what happened to this signal? If you increase, well, I'm sorry, I mean not k. If you increase the n, the capital N, what happened if you increase capital N? What would you think would happen? What would happen to xn if we increase if we increases if we increase capital N? What would happen if we increase capital N? Anyone? Yes, okay. Gritawat, okay. The periods would increase, okay, according to N with more zero padding. Exactly. Okay, with more zero padding. Okay, with more zero padding. Yes. Okay. So this one means if you increase and make it continuous, right? If you increase and you get more zero padding, so you can see that it becomes, if you increase, right, it's going to becomes the DTFT. Okay, it's going to go back to this one. See, it's going to go back to this one. Period will go to infinity, okay, with zero padding. Okay, so this is what happened in Fourier domain, the relationship between the Fourier domain and the time domain. Okay, and that's pretty much it. Okay, so this is what we have for inverse DFT. Okay, DFT. What happened if n is not 3? Okay, remember this function here. Okay, xn has 3 samples, at most 3 samples, the rest are zeros, right? Xn has at most 3 samples, the rest are 0. However, for this problem, if we use n only 2, what happens if you use only 2, n is capital N only 2? Guess what's going to happen? Mm. Can you guess what's going to happen if n is less than 3? If capital N is less than 3. Okay, this is a very interesting problem. Not increase, the period is not increase anymore, right? The period will reduce now. If it's less than 3, alternating between 0 and 2. Kita what? Well, not quite. Only one sample? No, it's going to be periodic with only two samples. But it's probably not between 0 and 1, 0 and 2. I'm not sure. Okay. The rest, you are not really answering these questions. Okay. Increase the same sampling less than 0. No. Okay. Let's try this. Okay. When n is equal to 2. Okay. If n is equal to 2, what happened to the equation? The equation is what? 1 over 2, right? The equations can be 1 over 2, according to this equations. Summing n from k, right? Summing k. Summing k from 0 to 1, right? And 2 minus 2j psi what? 2 pi over 2 k times e to the plus j 2 pi k over 2 n. Okay. So in this case, okay, let me call this term, okay, for convenience, okay, a lot of times we call this term WK, okay. If this term is WK, the whole thing here is WK to the power of N, okay. So in this case, we got only two Ks, right? So this one we got what? Capital X. This is capital X0 and capital X1. Okay. Capital X0 is just K equal to 0. Psi 0 is 0. So it's just a 2. And capital X1, psi 1 is psi pi. Okay. Psi pi, right? When K is a 1, psi pi. How much is psi pi? Psi pi is 0. No, it's negative 1, right? So it's a psi pi is negative 1. Negative 1 times, is it? No, it's 0. It's also a 2. Okay, psi pi is 0. So it's also a 2. Okay, that's the rules. Okay. Okay, so it's a 2 and a 2. And this one we got omega w wk is e to the j pi k. How much is e to the j pi k? Got to be careful here. Okay, so you got 0k, k equal to 0, k equal to 1. This is when k is even, and this is when k is odd, right? We can add a 1 or a negative 1, okay? So it's equal to negative 1 to the power of k, okay? So, and that's when k is 0. So it's negative 1 to the power 0 is 1, right? This is 1 to the negative 1 and negative 1 to the negative 1. Okay. This is when k is 0 and that's k is 1. The first column is when k is 0, right? The second column is when k is 1. Okay. And this is 1 to the 0, negative 1 to the 0, 1 to the 1, and -1 to the 1, 1 to the square, and -1 square, 1 to the 3, and -1 third, and 1 fourth, and -1 to the fourth. Okay, multiply them. What you get? Oh, you're right. Actually, it's 0 to 0 to 0 to. Yep. Okay. Where is this come from? Okay, it's periodic with period 0 2. Okay, so you got 0 2 0 2 0 2 0 2. It's periodic like this. Yeah. Who was right actually? Yeah, Gitawat, you're right. Okay, it alternates between 0 and 2. Okay, it's alternate between 0 and 2. Okay, but the question is, you get what, you're right. Okay, but the question is, where is this alternating between 0 and 2 come from? Yeah, the interesting part is where it's come from. Okay, it's actually came from here. If you notice, well, you got to be very not very observant, okay, to notice this. Okay, it's just like this. Okay, it's just like this. Originally, we have the signal, what? 2. This is xn, right? Xn. Uh, what? Let's go here. Here, like this one. Okay. It's this one. Okay. Except you shifted one period, right? How you get 0 2 0 2? Hmm. Yeah, it's like this. Okay, we got -1. How can I do this? Okay, it comes from here. -1 to 1, -1 to 1, right? -1 to 1. It's supposed to be this series, okay, this sequence, okay? And then you shift it by 1, okay? You can doesn't matter if you shift to the right, you shift to the left, I think. So you shift it by 1, -1 to 1. Okay, how about I use the green one? It's shift to the right, the global one. So it's -1 to 1, -1 to 1. Is it working? How come it's 0? It's going to be 0, 1, 3. Oh, how come it's not? It's not 0, 1, 3. It's like merging somehow. Well, 0 and 2, where is it from? Hmm. It's not shifting, but it squeezes the signal, right? 0. It's like this one and this one combined. Oh, I see. It looks like this, right? I'm sorry. This is wrong. It's more like overlap. We call it circular overlapping, I think. Okay, it's supposed to be -1 to 1 like this, right? And then you have the other one is going to be -1 to 1 like this. Yeah, okay. Yep. And the next one can be like -1 to 1 like this. Okay. And if you sum them up, yeah, okay, it repeats itself, but when it repeats itself and not overlapping, and it's overlapping, right? It repeats itself, it's periodic, but repeat itself, but there's some overlapping. Okay, it doesn't go far. Okay, that's the reason why it's not doesn't go far enough. Okay, that's the reason why you get and this one on the right hand side is gonna be like 1 to -1 like this. Okay, so at the end we have 0 to 0 to 0 to, yeah, okay, it's like that. Okay, that's why we get this one. Okay, it came from the fact that it shifted. Okay, it shifted, but it's not too far. Okay, you because you sample too little. Okay, this effect is called aliasing. Okay, this effect is called aliasing because you sample the frequency not enough. Okay, the sampling frequency is not enough. Okay, you need sampling frequency to be high enough to avoid aliasing. Okay, aliasing means when you shift it over, right? It's not go beyond. Okay, so there's some overlapping part. Okay, it's called aliasing, and that's pretty much it. Okay, for DTFT. Okay, so before we continue, let's review some other things. Okay, for here. Okay, okay, Fourier series. Okay, sometimes we call it CTFS. Oh, how about no, not yet, not yet, not yet. I'm sorry. Okay, well, yeah, actually, we call it CTFS. Okay, but I just call it Fourier series because it's the original Fourier series. Okay, but I think in the book they call it CTFS, continuous time Fourier series. Okay, XT in the time domain is periodic, right? It's periodic. Okay, in the time domain, it's supposed to be periodic, continuous time. Okay, it's periodic, continuous time. CK is what? Discrete frequency, non-periodic, right? It's non-periodic, discrete frequency. Okay, it's non-periodic frequency, discrete frequency. For the CTFT, what's the CTFT? Tell me. What's XT in CTFT? What's the characteristic of XT in CTFT? What's the characteristic of CT in ZSOC? Time domain function. Yeah, what's the characteristic of that? What's the characteristic of it? Can you tell me? Both of them are non-periodic, right? And both of them are continuous. Okay. This one is non-periodic. Both non-periodic. Both of them are continuous. Okay, continuous. This is continuous time. This is continuous frequencies. That's easy. Okay. How about the TFT? DFT is XN. Is SN periodic or non-periodic? XN is non-periodic, right? Non-periodic discrete time. Okay. However, x of omega, x of e to the j omega is periodic, right? This one, xe to the j omega is periodic. Okay. Continuous frequencies. And the DFT, okay, the DFT here, XN, where's the XN? Okay, this XN is periodic with period N. Okay, so this is periodic. Okay, discrete time, of course. XK, this XK is also periodic, discrete frequency. Okay, so if the basically if one domain is discrete, the other domain would be continuous, right? No, if one domain is periodic, the other domain would be discrete. Okay, discrete periodic. Okay, discrete periodic. Okay, if it's non-periodic, then it's not discrete. Okay, it's continuous. Okay, if one domain is continuous, the other domain would be non-periodic. If it's continuous, the other domain would be non-periodic. If this is continuous, the other domain will be non-periodic. If it's continuous, the other domain will be non-periodic. If it's continuous, the other domain non-periodic. Yeah. Okay. This one is one discrete, the other one will be periodic. You can see the matching between periodic and continuous. Okay. We have covered all of them. Okay. Except for the last one. Okay. So the DTFT. Okay. The DTFT. The
Excuse me,
formula for
what,
the DTFT. Yes.
can you explain about the relation again?
If one domain is periodic, the other one would be discrete. That's
Oh,
all. Okay. If one domain is continuous, the other domain must be non-periodic. Okay. So it just says if one domain is discrete, the other domain must be periodic. Okay. It could be time or frequency. Okay. So one domain discrete is discretized, the other domain must be periodic. Okay. Okay, let's recall the DTFT. The formula for the DTFT. Okay, this is gonna jump into what's the formula for the DTFT. The formula for the DTFT is summation of xn, right? E to the power of negative j omega n, n from negative infinity to infinity. Okay, now we're gonna derive DFT. Okay, DFT is xk, right? It's gonna be similar to the one above here. Okay, except you change this omega, we change this omega into 2 pi k over capital N, right? And this infinity, negative infinity to infinity, this n from negative infinity to infinity is just n from 0 to capital N minus 1 because xk supposed to be periodic. Well, because xn, I'm sorry, this is because xn is periodic with period capital N. Okay, but the one above for the DTFT, xn is non-periodic. So you integrate, you sum from negative infinity to infinity. Okay, this one is non-periodic. Okay, there is a parallel connection here. Okay, if it's periodic, you sum just one period. Okay, if it's non-periodic, you sum for all values. Okay, that's all we have. Okay, this is pretty much we have. We have four things: CTFS, CTFT, DTFS, and DFT. The problem is, what is DFT? Okay, how come it's not? How come it's not what? How come we call DFT, but not? What's missing here? The last one that's missing is DTFS, right? DTFS, discrete time Fourier series. Okay, how come it's not discrete time Fourier series? How come it's just DFT? Okay, it's so confusing, huh? Okay, well, it's happened. This is the way they derive from the way they do. But then we're gonna compare CTFS. Okay, representations. What is the CTFS representations? Do you remember? What is it? The CTFS representation is summation, right? Summation, if you go back to the first chapter, is CK, e to the power plus j k omega naught t, right? K from negative infinity to infinity. Okay, and where CK, okay, where CK is what? 1 over t, right? Integral of xt with period t, right? E to the power of negative j omega naught t. Integral from for one period, capital T. Okay, integral for one period, capital T dt, right? There's a k omega naught t right here. K omega naught t. Okay, this is our CTFS. But for the DFT, discrete Fourier transform, okay, for the DFT, we got this one, right? Xn, okay, I use X subscript N now. Okay, Xn would be what? This one would be summation. How about I use a different color? Would be summation of xk, right? Summation of the frequency xk e to the power of, oh, here, if you go back to the definitions before, okay, here, the definition of here, the xn is 1 over n summation of xk e to the power of j 2 pi k over n. Okay, there's 1 over n here. Okay, there's a 1 over n here, and e to the plus j 2 pi k over capital N, n, right? K from 0 to capital N minus 1. Okay, where xk, okay, xk is this one, summation of xn, okay, is this one here. Okay, e to the minus j 2 pi k over capital N times n from 0 to n minus 1. Okay, what do you see? The difference between the two. Can you compare the orange one and the purple equations? What do you see the difference? You see anything? They are not quite the same. They're pretty similar, but not quite the same. Okay, the integral becomes the summation. That's all right. But the factor of 1 over n and 1 over t are at different place. Okay, this factor 1 over t is here, but this factor 1 over n is here. You can see it's not exactly DTFT. Okay, see DTFS. So if I move this into 1 over n here, okay, if I move it here, 1 over n, go in there. Now, this 1 over n x, oops, I'm sorry. Okay, if I move 1 over n in here, okay, this 1 over n xk will be equivalent to ck. Okay, would be equivalent to ck, right? Yep. Okay. Now, if I call this one x tilde k, okay, if I call this one x tilde k equivalent to ck. So in the frequency domain, I would multiply by 1 over n here, and I multiply by 1 over n here. And this 1 over n would be equivalent to this 1 over t. See, 1 over n will be equivalent to 1 over t, and this xn, which is supposed to be periodic, right? This is supposed to be periodic with period n. Oops. Okay, is equivalent to xt above. And the integral becomes summations. Everything is equivalent. Okay, and 1 over n xk is just x tilde k. Okay, so we come up with the DTFS, discrete time Fourier series, as this one. X tilde k is 1 over n, right? This is x tilde k is here. 1 over n times summation of xn e to the negative j 2k 2 pi k over capital N. And that's the inverse DTFS. Okay, So this is the inverse DTFS. Okay. In other words, okay. In other words, what does it mean? The DTFS and the DFT. Okay. In other words, the DFT, DFT, discrete Fourier transform, and DTFS. Okay. The different, they are exactly this, well, not exactly the same. They are very similar. The only difference is that DFT we use capital K. DTFS we use X tilde K. Okay, and X to the K is just 1 over N times XK. See that? Okay, this is the relationship between DFT and DTFS. Okay, discrete Fourier transform and discrete time Fourier series. Okay, it's just the difference between uh, the difference is by a factor of 1 over N. Okay, the difference is by a factor of 1 over N. All right, that's pretty much it. Okay, this is very important. Okay, if I ask you to find DFT or DTFS, okay, they are similar. Okay, and that's it, I guess. The rest is the rest are homeworks. Yeah. Okay, I'm gonna give you homeworks over the weekend, I guess. Okay, this one we want to find the rest are easy. Well, but you have to remember DTFS got to be periodic. Okay, got to be periodic with period, capital N. Okay. Oh. Any other questions? Yeah. Okay. For example, suppose I think that's pretty much I have.
Professor, are you going to show page 99 or do we need to find it out on our own?
99 is nothing. Is we have talked about it before the midterm. This is before midterm. It's about the sum of two periodic functions, discrete time periodic function. Is it? We don't need to. Cosine n is non-periodic. It's the same as the one before the midterm. Okay, we can ignore that. This is non-periodic. This one is periodic with some period. What's the period? Capital Pi, capital N. Uh, it's before midterm. This is before midterm. Yeah, we did in time domain already about periodic functions. Okay, we don't need that. 99. Okay. For the DTFS, this one just put in the equations here. Okay, if you want DTFS, it's x tilde n, x tilde k, right? X tilde k would be 1 over n. How many n are there? Periodic. 1, 2, 3, 4. So it's 1 over 4 times what? Uh, this, right? We need that formula. Okay. Summation of xn e to the uh, negative j 2 pi e to negative j 2 pi k over 4 n, k from 0 to 3. Okay, this is periodic from 0 to 3. Yep. And so you need you need x tilde 0, x tilde 1, x tilde 2, and x tilde 3. Okay, you need 4 samples for each of them. So you got 1 4, and then this one and this one. This one you need xn, right? And so xn n from 0 to 3, we got what? Oh, oh, they didn't show you this. Let's put the number in. Okay, put the number. This is -1 to 1 0. So it's -1 to 1 0. And let's call this whole thing W subscript K. Okay. Uh, this is the K, right? This is K equal to 0. This is K equal to 1. This is K equal to 2. This is K equal to 3. And that's the N, right? This is N equal to 1, N 0, N equal to 1, N equal to 2, and N equal to 3. So this one would be W0 to the 0, W0 to the 1, W0 square, and W0 to the third. W10, W11, W12, W13, W20, W21, W22, W23, W2, W30, W31, W32, and W33. Okay, the question is how you calculate the W, right? Yeah, that's 1 4 times what's W00. If K 0 or N is 0 is a 1, right? So you got 1 1 1 1. K 0 is a 1 1 1. Okay. -1 to 1 0. What is W11? W11 would be e to the power of -j. W11 is e to the power of -j 2 pi over 4. How much is -j 2 pi over 4? 2 pi over 4 is pi over 2. It's right here. It's 1 plus j. Oh, it's negative, right? Negative 2 pi over j is here. Negative. This is negative e to what? The phase is pi over 2, right? Negative pi over 2. Phase is negative pi over 2 is right here. So it's, no, that's not negative pi over 2. That's pi over 4. Where is pi over 2? Negative pi over 2 is here, right? This is negative pi over 2. So it's negative j. Okay, negative j. And then square of negative j, we got -1. And multiply by another negative j, we got a j. Okay. And for this one, what? For this one, W21 is e to the negative j, 2 pi over 4 times 2. So it's e to the negative j pi. Negative j pi is here, right? Negative j pi, negative pi, right? negative pi is here. So it's negative 1. And then you got another, you square it, you got this one is a 1 and negative 1. Okay, so it's alternating between this and that. Okay, and the last one is this one, W31. W31 is e to the negative j 2 pi over 4 times 3 times 1 is 3. So it's e to the negative j 3 pi over 4. Where is 3 pi over 4? No, 3 pi over 2. Negative 3 pi over 2 is pi over 2, 2 pi over 2, 3 pi over 2 is here. Right? So it's a j. Okay, it's a j. And then you square it. That means you go to 6 pi over 2, negative 3 pi over 2, negative 6, 1, 2, 3 is negative 1. And then 1, 2, 3 is j. Okay, and multiply them and whatever you get for the answers. Okay. Oh, oh gosh. All right, I think that's it for today. Okay. I'll give you homeworks problems to practice on. Okay, to find these free series, DTFS and DFT. Okay, DTFS and DFT. Okay, any questions? Okay, for the DTFS and DFT, mostly about calculators. Okay, you need a good calculator to calculate the summation, or maybe you need to know how to multiply matrices. Okay, it's just summation. You don't need to do any integration. Okay. All right, that's it.
อาจารย์ครับ
ครับผม
what did you just say? The mic was a bit uh, was hard to hear ครับ the last part นะครับ about summing something.
DTFS or DFT. Okay, DFT or DTFS. These two are about just summation. There is no integrations. Okay, you just need calculator, good calculator to calculate all the summations. Okay, all you can do is like multiply the matrix like this. Okay, it's nothing hard but tedious. Okay, there's nothing hard about this chapter. Okay, it's but the summation it can be tedious. Okay, most of the time we do it using computer, of course. Okay, we don't really sum them by hand. Okay, but if you do in the homeworks or in the exam, okay, you might need a good calculator to calculate the sum. That's all. Okay.
โอเคครับ
ครับผมนะก็ไปฝึกบวกเลขเยอะๆนะครับผมฝึกบวกเลขครับก็คูณ matrix or multiply matrices like this. Okay. Yeah, it's gonna be a little bit hard, but it's manageable. Okay. And next chapter is about filters. Okay, we're gonna talk about filters. I think we have two more topics left. Filters and Z transform. Okay, that's all we're gonna do. Okay, I think we have just in time. Okay, we don't have class on Friday though. Okay. All right. Anyone have any questions?